Our last section in Chapter 5 is 5.7, known as linear inequalities. Up to this point in this class, we've done a lot with linear equations. For example, I might ask you to solve 3x plus 2 equals 9. That would be a linear equation. What makes that a linear equation?
The equal sign.
It's got an equal sign. That makes it an equation. And then why is it linear? There's no y, though. To say y equals mx plus b really doesn't make any sense because there's no y. In math, what does linear mean? It doesn't always mean y equals mx plus b.
Linear means it's a variable.
It means there's a variable, and there's something special about the variable.
Being times by something.
For example, if I were to write this, it would no longer be linear. Why not? What's wrong with 3x squared?
Oh, you can't have an exponent with a variable.
Correct. There's nothing wrong with 3x squared, but it would no longer be linear. So when I say it's linear, what I mean is the variables all have a power, and the power is exactly 1. That's what we mean by linear in math. Okay? How would you solve that linear equation? Subtract 2 and then divide by 3. So our answer would be x equals 7/3.
So linear means all variables have power of 1.
Linear means all variables have power of 1. That is correct. In this section, we're going to talk about linear inequalities. So we're still going to have all the exponents having a power of 1, or all the variables having a power of 1. What's the difference between inequality and equation?
It's not an equation.
It's not an equation, that's true. What is it? It's an inequality. It's kind of circular. How will we recognize what an inequality looks like? It won't have an equal sign. What will it have in between instead? It might have a less than, or it might have a greater than, or a less than or equal to, or a greater than or equal to. So, inequalities involve 4 symbols. We have the less than symbol, the greater than symbol, the less than or equal to, and the greater than or equal to. We have one of those 4 symbols. All right, so I have some true or false questions. True or false? True or false?
True, less, or false.
True. 6 is greater than -2. So it's true.
Okay, so what is this symbol? This symbol is? This is the less than symbol. So this would be read, -2 is less than 6. True or false? -2 is less than 6. That's true. How would you read that one?
-3 is greater than or equal to -5.
You would read that one as -3 is greater than or equal to -5.
It's not equal.
It's certainly not equal to. So is it greater than? Is -3
No.
greater than -5?
Yes.
It's false.
Closer to 0.
But if it's not equal to, it has to be false.
It's greater than or equal to. It's one or the other.
Oh,
It doesn't have to be both. It's not greater than and equal to.
Okay.
It's one or the other. So is -3 equal to -5? No. Is -3 greater than -5?
Yes.
So is it greater than -5 or equal to -5?
Yes.
Yes. So that one is also
True.
that one is also true. Eight is less than or equal to 8. That's true because
It's equal.
8 is equal to 8. All right, that was true.
It was some false.
Oh, give us some false ones? Okay.
Well, now you know the next one's going to be false.
Now you know the next one's going to be false. Well, you give me a false one.
6 is less than 9. Or I mean greater than 9.
About 6 is less than 4. Is 6 less than 4?
No.
No, so that one would be... See, it's not so easy to make up false ones, is it? 6 is less than 4. False. Negative 2 is greater than or equal to negative 12. True. See, it's hard for me to write false ones. I always put them in the right order. Well, I'll make up a false one now this time. Negative 1, less than or equal to negative 7.
False.
That one's false. Told you I was going to make up a false one, and it was going to be false. Okay, now, if I give you x plus 1 greater than or equal to 6, give me some numbers that would make that true. 5 would make that true. Why would 5 make that true? Because 5 plus 1 would be 6, and 6 would be equal to 6. So some solutions.
And then honestly, anything over 5.
Yeah.
So for example, 6
Yeah.
and 9 and 7. Sure, we do them in order. In fact, you just told me what all the answers were. What were all the answers?
Everything over 5.
Everything 5 and bigger. So how would we write the all solutions?
X is greater than or equal to 5.
X is greater than or equal to 5 would be a list of all the solutions. Now, when I say all the solutions, I'm also including all the fractions and decimals. For example, would 5.1 work? Yes, because if I plugged in 5.1, 5.1 plus 1 is going to be 6.1, and that would be greater than 6.
So if we got something like that, then the answer would be all solution is x greater than or equal to 5?
Right. And what I want to warn you about, some people, if I give them x plus 1 greater than or equal to 6, they'll write x equals 5, 6, 7, ... And I'm going to mark that wrong. Why am I going to mark that wrong? Because it's not the answer. All those answers are correct.
But you're thinking that they're all going to be added to that 1, right?
Uh-huh.
It's not going to be 6.
Well, it's going to be more than 6. It's going to be more than 6, though, right? But that's still not the right answer. Why not?
It's not equal to.
Well, we got the equal to. If I plug in 5, I got the equal to.
It doesn't include the fractions.
It doesn't include all the fractions and decimals. So you're not going to write your answer this way. You're not going to write x equals 5, 6, 7, ... because you're missing a lot of answers.
Could another possible solution be x is greater than 4?
No. And let's talk about that. So the right answer, you're not going to write your answer that way. You're going to write x is greater than or equal to 5. What if you write your answer as x is greater than 4? Is that correct?
No, so it could be like 4.1, 4.2.
Because it could be 4.1, 4.2. You got to remember there are lots of fractions and decimals in between 4 and 5. So no, that's not a correct answer either.
Look at x is greater than 4.999999 repeated.
X is greater than 4.999 repeated. Still wrong.
It's not 5.
Why not?
It would only be 5.9999.
If you were to put that, it would be correct. 4.99999 repeating forever is exactly the same as 5. You thought you were funny, but 4.999 repeating forever is exactly the same number as 5. Yeah. Don't believe me?
I do. We've been doing it for 25. I believe.
Well, here's my answer as to why they have to be the same. If they're not the same, then there has to be a number in between them, right? So what number is in between 4.99999 repeating forever and the number 5?
I don't know.
There isn't one. So they have to be exactly the same. So, kind of a philosophical argument there. All right, so basically what we're going to do in this section is we're going to solve linear inequalities. And the good news is you already almost know how to do it. How would you solve 2x plus 1 equals 5? Is that a linear inequality?
Oh.
No, that's a linear equation because it's got an equal to sign. How would you solve that?
Minus 1.
Subtract the 1. 2x is 4, and then divide by 2. How do you think you solve 2x plus 1 greater than 5? That's now a linear inequality. Subtract the 1. 2x greater than 4, and then divide by 2. So x is greater than 2. So you do it exactly the same way as you do a linear equation. Well, it can't be quite that easy, right? There's one little trick, one little rule. If you multiply or divide by a negative number, you must change the inequality symbol. So that's the only different rule. And let's talk about why you have to do that. Give me two numbers.
-4.
-4
3.
and 3. If I were to write down the numbers -4 and 3, what kind of symbol would I put in between them? Less than. -4 is less than 3. What if I now took this and I multiplied both sides by a negative number? Give me a negative number that you like.
2.
-2. If I multiply by a negative number, I'm now going to have 8 on the left and -6 on the right. Which way does my symbol have to go now?
The opposite.
It has to be greater than. So notice what happened. I started with a less than. When I multiplied both sides by a negative number, I had to flip my symbol. It has to go the other way. That's the only way it works. Let's try that with divide. How about give me two numbers again. What?
-1.
-1 and -3. Which way should my symbol go?
Greater than.
Greater than. Now give me a negative number that you want to divide by.
7.
I was hoping you'd pick an easier number, but we'll go with 7. All right, so if I divide both of these by -7, I now have 1/7 on the left, and I have 3/7 on the right. Which way does my symbol have to go? It has to go, I have to change my symbol. 1/7 is less than 3/7. Okay, so now let's go back up and change this problem ever so slightly. If I give you -2x plus 1 equals 5, what do you do to solve? Subtract 1. -2x equals 4. Divide by the -2, you write x equals
2.
-2. However, if I give you -2x plus 1 greater than 5, you do it exactly the same way. You subtract the 1. -2x greater than 4. But then what's going to happen when you divide by that -2?
X is less than.
You're going to have x is less than -2. So there's the one rule that you have to remember. When you divide by a negative number, or if you happen to multiply by a negative number, You've got to flip that inequality symbol over. Questions on that?
That was on a test. Would you mark the whole question wrong if we didn't flip it at the end, or did you just take points out?
I would definitely take lots of points off. Absolutely. Other questions?
Are we going to graph this?
Are we going to graph these? That's a wonderful idea. Absolutely, we're going to graph these. All right, so how do we graph these? We graph them on a number line. So we draw ourselves a number line. I'm going to mark -2, there's 0, there's 2. I'll just mark a couple points there. How do you graph that?
Don't you put the point and then like draw an arrow in a direction? And then like if it's not filled in, it's just equal to or just greater than or less than. But if it's filled in, it's greater than or equal to or whatever, something like that.
You're absolutely correct.
Okay.
In this case, I only have a less than symbol. When you only have a less than symbol, you're going to go to your number, -2, and you're going to put a circle right around there. If we had less than or equal to, we would fill in the dot. You're absolutely right.
Yeah, I saw something.
Yep. And then we shade one way or the other. In this case, we want all the numbers less than -2. So which way do we shade?
There's no equal to, so it doesn't have to, the bubble doesn't have to be shaded.
Correct. If there was an equal to, I would shade that dot in. But there's no equal to, so I just put a circle. Less than tells me to shade to the left or shade to the right? To the left. So I shade this way. That would be my answer. The other thing you're going to be asked to do is you're going to be asked to write your answer in what's called interval notation. And here's the way interval notation works. You look at your answer. You're going to write two things. You're going to write your smallest number and your smallest thing and your biggest thing. Shaded here. How far left does this go? What's the smallest thing?
Indefinite.
Indefinite. So what would we write? Except it's negative infinity, isn't it?
Negative.
Going to the left. So our smallest thing, this one goes all the way forever to the left. So that's negative infinity. And then how far to the right do we go?
-2.
We stop at -2.
Oh,
Infinity and negative infinity always get a round parenthesis. The other one gets a square if you have the equal to in the original problem. We don't have an equal to, so we're going to give this -2 also a round parenthesis.
Now, if the infinity ends up being on the right side, then it would be a square always, right?
Infinity always gets a round one.
Always, okay.
The only time you're going to have a square is when you have an equal to. So let's do one with an equal to, and you'll see what I mean. How about -3x plus 2 less than or equal to 5? What would you do to solve that inequality? Subtract 2's. So -3x. When I subtract 2, do I flip my symbol? No, I'm not multiplying or dividing, I'm just subtracting. Less than or equal to 3. Now I divide both sides by -3. What happens when I divide by -3? I've got to flip it. So it becomes x is greater than or equal to -1. I draw my number line. Here's -1, here's 0. You don't have to mark a lot of numbers on your number line. Just a couple is good. What do I write at -1?
circle.
A circle, and then I fill it in. Why do I fill this one in? Because I have the equal sign. When I have the equal sign, I draw my circle, and I fill it in. Which way am I going to shade?
Right.
To the right. Why to the right?
Greater than.
Because it's greater than. So that would be my number line. Interval notation, I look at my answer. What's the smallest thing on the left?
-1.
-1. What's the biggest thing on the right?
Infinity.
Goes to the right forever, so that's infinity. Infinity always gets a round bracket. So for the infinity, I put a round one. The -1, however, the -1's going to get a square bracket. Why does the -1 get a square bracket? Because it's equal to. When you have an equal to, you get the dot, and you get a square bracket on the number. Questions on that?
Why is it going to the right?
Because x is bigger than negative 1. So give me some numbers that are bigger than negative 1.
1.
1 is bigger than negative 1. So if negative 1 is here, 1 would be bigger. It would be to the right. Okay? Other questions? All right, so how about we solve? Oh, I don't know. How about 4x plus 2 greater than 6x minus 12? What would you do in order to solve that?
Subtract 6x.
You got to get all the x's together on one side. Now, I would highly, highly, highly recommend for inequalities you always put the x's on the left. Do you have to put them on the left? No. But it's much easier if you put them on the left at the end to draw your number line and write your intervals. So I'm going to suggest you always put your x's on the left for these problems. That gives us minus 2x plus 2 greater than negative 12. Next step, subtract 2. So negative 2x greater than negative 14. And finally,
Divide by -2.
and what do I have to do that's special when I divide by negative 2? Switcheroo. So x is less than 7. Number line? There's 7 and there's 0. What symbol do I put on 7? Just a circle? Do I fill it in? No, I do not fill it in. When I have just a less than, I'm going to get just a circle. Which way do I shade? To the left. I want numbers smaller than 7, so I shade to the left. Interval notation? Negative infinity to 7. Round brackets or square brackets? Both round?
Yeah.
Both round. No equal to's, so everything's going to get a round one.
Are you going to ask us to check this?
To check it? Probably not, but you could check pretty easily. How could you check pretty easily?
Any number less than 7?
Pick any number you like that's less than 7 and plug it in and see if it works. What's a number that you like that's less than 7?
0.
0 is the number you like that's less than 7. If I plug 0 in, I get 2 is greater than negative 12. Is 2 greater than negative 12? So I'm pretty sure I'm going the right way. Definitely wanted 0 to be one of my answers. Other questions?
So there's no square brackets because there's no equal to.
There's no equal to.
Okay.
The only time you have a square bracket is when you have an equal to. Yep. All right. Oh, well, these are fun so far. Let's see if we can make them hard. 2/3 x minus 5/6 greater than or equal to, I don't know, how about 1/6 x plus 1/12. Fractions always make them more fun, right? What would you do?
LCD.
You would find the least common denominator. All right, so you look at all your fractions. You got a 3, a 6, and a 12. What's your least common denominator for a 3, a 6, and 12? 12 would be your least common denominator. You gave me the greatest common divisor. 3 would be the greatest common divisor. What am I going to do with my LCD of 12?
Well, you can multiply by 12 to cancel it out.
I'm going to multiply everything by 12 to cancel out all the fractions. That's exactly what we did when we had equations. You do the same thing here. If you have fractions, don't let the fractions bother you. Multiply everything by the common denominator and make all those fractions go away. How much is 2/3 times 12? It's 24 over 3, but 24 over 3 is 8. So that's 8x minus, what's minus 10, because I would reduce here. 12 divided by 6 is 2. 5 times 2 is 10. Greater than or equal to
2x plus
2x plus 1. So again, don't let the fractions bother you. If you see a bunch of fractions, multiply by a common denominator and make them all go away. And then it's an easy problem. How would you solve? Subtract 2x. So that's going to be 6x minus 10 greater than or equal to 1. I think I heard somebody say subtract 2x, and I think I heard somebody say add 10. Does it matter which order you do those in? No. My personal preference is I usually deal with the x's first and then the numbers later. So I would add the 10 now. 6x greater than or equal to 11. And then finally divide. X is greater than or equal to 11 over 6. I do not flip my symbol this time. How come I do not flip my symbol? I'm dividing by positive 6, not negative 6. When you divide by a positive number, you don't do anything to your symbol. You leave it just like that. We draw a number line. Where's 11 over 6? It's 1 and 5/6. That's true. What I would do is I would say here's 0, and 11/6 is certainly bigger than 0. So that's how I would draw things. I would mark 0 and 11/6. Circle or dot? Dot, because we have the equal to. Shade right or shade left? Right, because it's greater than. Interval notation. How would you write interval notation?
I just have a question. How did you get that?
How did I get
I'm
what?
just confused. Like I just made a number like
Okay, so if you go 0, 1, 2, then where's 11 over 6? Yeah, so you're making it hard on yourself, aren't you? If you mark 0, 1, 2, like so, you need a dot at 11 over 6. So what you have to think about is 11 over 6 is a little bit smaller than 12 over 6. And 12 over 6 is a fancy way of saying 2. So 11 over 6 must be right about there, just a little bit smaller than 2. So you would have to do that. If you mark your number line 0, 1, 2, then you have to think of where 11 over 6 is. When I draw my number line, I tend to mark 0, and then whatever other number I need. If it's a negative number, I put it on the left. If it's a positive number, I put it on the right. And then I don't have to worry about all these fractions. It's just easier to mark two numbers, 0 and whatever one you need. And we would still shade to the right then, right? Look like that. All right, how about as an interval? What number goes on the left? 11 over 6. What goes on the right? Infinity. Tell me about brackets.
Square bracket.
Square bracket on the left. How about on the right? Round. Infinity always gets a round one. Why did the 11/6 get a square one? Because it had the equal to. Questions on that?
so the 11 over 6 got the bracket because it has the new.
Correct. We have the equal to back here. We have the equal to from the beginning. When you have the equal to, you get the square bracket. And when you have the equal to, you get the dot.
Okay.
Yep. Other questions?